On September 17, 1944, 14,000 feet above Eindhoven in the Netherlands, the inaugural day of Operation Market Garden witnessed the most massive airborne assault ever recorded, sweeping across the Dutch landscape. As thousands of Allied planes facilitated the deployment of paratroopers, formations of P-47 Thunderbolts patrolled the skies over the drop zones, carrying an astonishing payload of munitions that would have been considered utterly unfeasible a mere 18 months prior.
German Luftwaffe aviators rushing to intercept were met with a shocking revelation they had completely failed to foresee. Witnessing the appearance of these bulky American pursuit aircraft, laden with 2,500 pounds of explosives, which amounted to half the standard long-range payload of a B-17 Flying Fortress, the very warplane that enemy forces had casually rejected in 1943 as excessively cumbersome for dogfighting, had morphed into a devastating force, completely shattering their foundational concepts of aerial combat. Here was a single-engine, single-seat machine capable of battling its way to an objective, unleashing the destructive power of a light bomber, and subsequently fighting its way back to base. The evolution of the P-47 Thunderbolt from a dedicated interceptor into the European theater's most lethal fighter-bomber did far more than merely alter tactical approaches. It hastened the downfall of the Wehrmacht and permanently transformed the core doctrines of military aviation. German forces were entirely blindsided by the fact that pragmatic American manufacturing had forged neither a traditional fighter nor a standard bomber, but an unprecedented universal combat platform designed to execute any operational mandate with lethal efficiency. When the Republic P-47 Thunderbolt initially engaged in combat during April 1943, it appeared to validate every preconceived notion the Luftwaffe held regarding American aerospace engineering, presenting itself as massive and intensely powerful, yet seemingly devoid of European mechanical refinement. As the 4th Fighter Group executed the aircraft's maiden official combat sortie on April 8, 1943, German intelligence analysts scrutinizing the fresh American design arrived at utterly predictable deductions, interpreting the raw technical specifications as undeniable evidence of mediocrity. Stripped of its payload, the P-47 tipped the scales at an immense 10,000 pounds, exactly twice the unladen mass of a Messerschmitt Bf-109G. Its colossal 18-cylinder Pratt & Whitney R2800 double WASP radial engine churned out a staggering 2,000 horsepower, while subsequent iterations would eventually generate 2,300 and ultimately 2,800 horsepower. This monumental power plant was tasked with propelling an airframe that looked as though its creators possessed absolutely no comprehension of aerodynamic streamlining. Early aerial skirmishes only served to cement German preconceptions, as the P-47's initial operational radius of a mere 125 miles strictly curtailed its utility as a protective escort for heavy bombers. Furthermore, its ascending velocity fell short of its German counterparts, allowing both the Focke-Wulf 190 and the Bf-109 to maintain distinct superiority during medium-altitude turning engagements. Recognizing these vulnerabilities, enemy aviators swiftly devised strategies designed to lure the ponderous American machine into tight-turning duels or vertical maneuvers, scenarios where its sheer bulk immediately transformed into a fatal handicap. However, the Luftwaffe's technical specialists completely failed to comprehend that they were evaluating a warplane in its developmental infancy, harboring latent capabilities that would require another full year to properly unlock. The incredibly resilient architecture that contributed to its massive weight, which was constructed from heavy steel tubing and extensive armor plating, simultaneously empowered it to sustain catastrophic damage and transport unimaginably heavy external payloads. Originally envisioned for carrying auxiliary fuel tanks to enhance range, the underwing pylons were structurally engineered to bear up to 2,500 pounds of munitions, a staggering burden that would have effortlessly ripped the wings from nearly any other pursuit aircraft of that era. This monumental evolution was sparked not by sweeping strategic directives, but through sheer pragmatic battlefield adaptation. Throughout the latter half of 1943, P-47 aviators heading back to base from escort duties started engaging various targets of opportunity, mercilessly strafing railway locomotives, vehicular convoys, and exposed fuel depots. These improvised attacks yielded incredibly promising outcomes, largely because the 8 50-caliber Browning M2 machine guns, each capable of unleashing 800 rounds per minute, could spew 12.7 pounds of lead every single second, easily producing enough kinetic force to rupture a heavy locomotive boiler or utterly obliterate a transport column. By November 1943, the first formalized modifications for carrying explosives were implemented, with technicians outfitting both the fuselage and wing pylons with reinforced shackles rated for 500-pound bombs. On November 25, 1943, the 62nd Fighter Squadron executed the inaugural authorized P-47 bombing operation, launching a devastating strike against the Luftwaffe installation at Saint-Omer in France. During this historic sortie, 8 Thunderbolts, each hauling a pair of 250-pound explosives, effectively obliterated 2 large hangars and inflicted severe damage upon 5 grounded enemy aircraft. During the harsh winter bridging 1943 and 1944, both Republic Aviation and the United States Army Air Force's technical services drastically accelerated the Thunderbolt's metamorphosis. Structural engineers substantially reinforced the wing spars to safely manage asymmetric weight distributions in scenarios where only a single bomb was deployed. Concurrently, they innovated advanced electrical release mechanisms capable of operating flawlessly, whether cruising at 30,000 feet or skimming the treetops. And they integrated sophisticated targeting arrays, such as the K-14 computing gun sight, which could accurately compute precise trajectory angles for both diving and gliding strike profiles. Entering the early months of 1944, these technical enhancements had evolved considerably beyond the installation of rudimentary bomb racks. The integration of 4.5-inch M8 rockets, each delivering the explosive equivalents of a 105mm artillery shell, effectively granted the P-47 the terrifying broadside capabilities of a naval destroyer. A lone Thunderbolt could now comfortably transport 10 of these projectiles, alongside 2 separate 1,000-pound bombs, representing a significantly greater destructive yield than numerous twin-engine bombers were capable of hauling during the conflict's initial stages. The monumental events of D-Day on June 6, 1944, finally forced the Luftwaffe to recognize the terrifying behemoth the P-47 had truly become. Throughout that single chaotic day, Thunderbolt pilots completed an astonishing 1,985 sorties, unleashing 525 tons of explosives and expending 135,000 rounds of 50-caliber ammunition. Their relentless assaults decimated 86 train locomotives, 507 transport vehicles, 38 fortified gun emplacements, and 17 crucial fuel dumps, irrevocably proving that the machine the Germans once dismissed as a subpar high-altitude interceptor was now the undisputed titan of tactical air superiority. The legendary Luftwaffe aviator Günther Rall, cemented as one of history's most prolific flying aces with 275 confirmed aerial victories, repeatedly clashed with these formidable planes throughout 1944. During a 1996 interview with HistoryNet, he vividly remembered the terrifying capabilities of the P-47, stating that, "As you know, it was the very aircraft that shot him down, and German pilots immediately recognized its overwhelming dive velocity, which could reach up to 1,400 kilometers per hour, whereas their own Bf-109 maxed out at just 1,000 kilometers per hour. Rall discovered this disparity firsthand when he found himself relentlessly pursued, with absolutely no means of escape. Consequently, on May 12, 1944, he was decisively shot down by Thunderbolts from the 56th Fighter Group, permanently losing his left thumb during that fierce encounter. Today, you can find his battered aviator glove resting within the exhibits of the National Air and Space Museum. Following the conclusion of the conflict, R spent roughly 300 hours piloting confiscated P-47 aircraft at the German Fighter Leaders School in order to thoroughly assess the aerial prowess of the Allied forces. The unique capacity of the P-47 to seamlessly shift from a bombing role to a pursuit configuration presented an unsolvable strategic dilemma for the Luftwaffe. Consequently, enemy interceptors dispatched to hunt seemingly defenseless bomber squadrons unexpectedly plunged into lethal dogfights against heavily armed machines that had merely dropped their payload, instantly reverting back to rugged interceptors boasting overwhelming offensive strength. The sheer statistical weight of the P-47's carrying capacity engineered a logistical nightmare that defied the calculations of the opposing military planners. A conventional P-47 D-25 model was designed to haul a diverse array of explosive armaments, easily accommodating a pair of 1,000-pound munitions, 3 500-pound explosives, or a mixed arsenal of warheads, adding up to 2,500 pounds. Astonishingly, this payload equated to 62.5% of the standard 4,000-pound cargo typically carried by a B-17 during extensive strategic flights. Therefore, military analysts accurately considered this formidable fighter to possess roughly half the destructive capability of the legendary Flying Fortress. A mobilized unit comprising 16 P-47s could effectively unleash 32,000 pounds of high explosives, perfectly mirroring the offensive output of 8 B-17 engaged in standard combat operations. However, unlike the massive aerial dreadnoughts that launched from British runways only twice a week, these agile machines were capable of executing up to 3 distinct strikes daily from frontline airstrips. Consequently, a solitary fighter squadron possessed the theoretical capacity to drop a greater tonnage of munitions within 24 hours than a heavy bombardment group could manage over an entire week. The contrast in operational efficiency was absolutely staggering, as a single pursuit plane carrying a pair of 500-pound explosives demanded merely 1 aviator and negligible maintenance support, whereas a massive bomber, laden with 4,000 pounds of ordnance, necessitated a 10-man crew alongside extensive technical backing. The month of August in 1944 witnessed perhaps the most catastrophic display of tactical aviation dominance during the Files Pocket Offensive. While hostile divisions desperately sought to break out of their encirclement between August 12th and 21st, they were subjected to relentless bombardments by P-47s flying continuous daylight rotations. Thorough ground inspections later corroborated the sheer scale of the carnage inflicted during these operations, with authenticated kill claims from philoliths officially recording the obliteration of 112 tanks on August 13th. Subsequent tallies confirmed the devastation of 287 motorized transports on August 14th, 42 railway engines on August 15th, and an additional 89 horse-drawn carts by August 16th. To maximize their lethal impact, the aerial contingents of the 9th Air Force utilized a seamless relay strategy, ensuring newly armed squadrons arrived precisely as exhausted units withdrew for necessary refueling and rearmament. This uninterrupted cycle of destruction applied an inescapable pressure upon enemy formations, effectively paralyzing any attempts at maneuvering during daylight hours. Comprehensive evaluations conducted in the aftermath of the engagement indicated that roughly 1/3 of all adversarial transports annihilated within the besieged perimeter fell prey to airborne assaults, with the relentless P-47 formations claiming the overwhelming majority of those decisive victories. By September 1944, the expansive introduction of the 5-inch high-velocity aircraft rocket, commonly known as the HVAR, fundamentally evolved the P-47S into unparalleled armor hunters.
Every individual projectile was armed with a 60-pound explosive tip engineered to pierce the reinforced plating of any adversarial heavy armor, effortlessly overcoming even the dreaded Tiger and Panther variants. Fully outfitted, a single interceptor could lug 10 of these devastating rockets into battle, granting the lone pilot the horrifying ability to unleash the destructive equivalent of a concentrated artillery battalion salvo in just one sweeping run. Taking the tactical lead, the 362nd Fighter Group championed a methodical approach to utilizing these rocket munitions against fortified enemy columns. Comprehensive combat debriefings detailed their precise methodology, which involved initiating a steep, 30-degree plunge from an altitude of 5,000 feet and successfully discharging the payload upon descending to 1,500 feet. This calculated aggression yielded direct strikes on 30 to 40% of all fired projectiles, establishing a phenomenal rate of precision that thoroughly eclipsed the traditional accuracy metrics associated with ground-based bombardment. The freezing crucible of the Battle of the Bulge in December 1944 perfectly illustrated the maturity of the P-47 into an indomitable all-weather strike platform. Even as paralyzing blizzards and dense, icy fogs confined the majority of aviation assets to the tarmac, these resilient warbirds, augmented by British-engineered launch rails and advanced navigational dials, sustained their relentless sorties. Once the skies momentarily parted on December 23rd, pilots executed an astonishing 647 combat flights, eliminating upwards of 400 enemy transports. The cumulative data gathered between December 23rd and 27th paints a staggering picture of this dominance. 201 tanks, 1,930 motorized trucks, 953 horse-drawn wagons, 89 train engines, 512 railway carriages, alongside 47 critical bridges, were thoroughly dismantled or pulverized. The dawn of January 1945 uncovered yet another lethal proficiency within the aircraft's repertoire: the surgical demolition of vital crossings utilizing 1,000-pound munitions. Aviators belonging to the 56th Fighter Group engineered specialized maneuvers designed to obliterate sturdy railway bridges that had previously withstood the blunt force trauma of high-altitude bombing campaigns. A tightly knit formation of 8 P-47s could routinely plant their explosives with a 50-foot accuracy during severe 60-degree plunges, vastly surpassing the haphazard targeting of massive stratospheric bombers, which were considered fortunate if their ordnance landed anywhere within 1,000 feet of the intended mark. The introduction of the Mi-262 jet interceptor during the opening months of 1945 was entirely expected to completely shift the balance of aerial warfare. Boasting an overwhelming velocity advantage of 100 miles per hour over the propeller-driven P-47s, this groundbreaking jet appeared virtually untouchable in traditional dogfights. Nevertheless, the continuous adaptation of the Thunderbolt into an aggressive ground assault weapon exposed a fatal flaw in the enemy's cutting-edge technology. Because the Mi-262S demanded extensive paved airstrips and devoured aviation fuel at an astronomical pace, their vulnerable staging grounds quickly devolved into prioritized hunting zones for marauding Allied fighter-bomber squadrons. A prime example of this tactic unfolded on March 21, 1945, when pilots of the 365th Fighter Group ambushed JG-7's Mi-262s as they desperately attempted to launch from Lipim Airfield. Trapped while gaining momentum along the tarmac, the revolutionary jets lacked both the agility and the requisite velocity to evade the sudden onslaught. In a mere 5 minutes of concentrated strafing, 8 of these irreplaceable Mi-262s were reduced to burning wreckage, representing a catastrophic material loss that vastly exceeded what the Luftwaffe was capable of manufacturing over an entire week. The sweeping initiative, known as Operation Clarion, launched in March 1945, orchestrated the methodical dismantling of the adversary's entire logistical infrastructure by roaming tactical aircraft.
Formations of P-47s were allocated specific geographical grids and issued uncompromising directives to obliterate any object that possessed the capacity for movement. The sheer scale of destruction was highlighted on March 22nd alone, when these squadrons laid waste to 89 train engines, 1,026 cargo carriages, and 155 terrestrial transports, while simultaneously collapsing 17 structural bridges and successfully severing 93 crucial railway arteries. This dramatic metamorphosis of the aircraft relied upon an unbroken chain of mechanical innovations and engineering upgrades. Rolled out in the middle of 1944, the fearsome P-47 D-25 variant showcased strengthened wing structures rated for a 3,000-pound external burden, adaptable mounting brackets capable of securing both domestic and Allied munitions, and streamlined zero-length rocket launchers designed to minimize aerodynamic resistance. Furthermore, this iteration featured enhanced thermal management for prolonged low-level operations, paddle blade propellers to quicken acceleration, a revolutionary water injection system that spiked engine output to 2,800 horsepower, and the advanced K-1414 computing gun sight to guarantee pinpoint strike accuracy. All while Republic Aviation's manufacturing hubs in Farmingdale and Evansville showcased an astonishing adaptability in their assembly lines. Manufacturing output eventually hit an impressive daily rate of 35 P-47 airframes, accompanied by the creation of 28 primary models and 430 distinct field modification packages. These manufacturing facilities managed to sustain uninterrupted assembly lines for 48 consecutive months without ever pausing for structural overhauls, representing an industrial achievement that no competing fighter producer could equal. Converting these aviators from dedicated dogfighters into versatile multi-role warriors demanded entirely unprecedented educational strategies from military leadership. The United States Army Air Forces instituted rigorous preparation protocols demanding a minimum of 200 flight hours prior to deployment, encompassing 50 simulated bombing approaches, 20 rocket firing exercises, 100 ground attack sweeps, 40 hours of instrument navigation, and 30 hours of flying in formation. This exhaustive instruction stood in stark contrast to the late-war preparation of Luftwaffe airmen, whose pre-combat flight experience had plummeted to a mere 110 hours, completely devoid of any ground attack instruction for their interceptor pilots. By the time they reached the front lines, you would find American airmen exhibiting profound mastery across a spectrum of duties, flawlessly shifting between high-altitude bomber protection, low-level navigational strikes, dive and glide bombing, rocket deployment, napalm drops, and strafing runs as the combat situation dictated. The second month of 1945 marked the operational debut of napalm payloads equipped on these aircraft, utilizing 150-gallon external tanks loaded with jellied petroleum. These improvised munitions proved capable of completely incinerating sprawling urban sectors or heavily fortified woodland entrenchments. The 362nd Fighter Group executed the initial combat deployment of this incendiary weapon on the 14th of February 1945, targeting a concealed Wehrmacht logistical hub nestled within the Reichswald. A strike force of 8 fighters, each armed with a single gelled fuel canister alongside a 500-pound explosive, ignited a massive conflagration that could be seen from 20 miles away, obliterating 3 acres of essential provisions in a matter of moments. Between March and May of that final war year, you could witness this formidable machine reaching the absolute zenith of its developmental arc. The P-47M variant entered active duty, boasting top speeds of 470 miles per hour, delivering aerodynamic performance that rivaled the earliest jet-powered aircraft of the era. Simultaneously, engineers crafted the P-47N specifically for the sprawling distances of the Pacific Theater, showcasing a staggering operational radius of 2,350 miles while fully laden with ordnance. However, the true revolution in military combat stemmed directly from how these squadrons were tactically utilized on the battlefield. You would routinely observe these versatile machines functioning as airborne coordinators, guiding Allied planes, serving as aerial artillery spotters, snapping crucial reconnaissance photographs, relaying vital radio communications, dispensing psychological warfare leaflets, and dropping emergency rations to besieged infantrymen. Astoundingly, a single variation of this airframe might execute half a dozen entirely distinct operational categories within a single 24-hour period. Analyzing the exhaustive statistical data from these campaigns clearly illustrates the unprecedented scale of this aerial transformation. A staggering total of 15,683 units were constructed, solidifying its status as the most heavily manufactured American fighter, with the Republic facility in Farmingdale rolling out 9,086 airframes, the Evansville plant contributing 6,242, and Curtiss-Wright in Buffalo adding 354. Despite this relentless output, hitting peaks of 35 planes daily, the records indicate a perplexing documented cost shift involving $15,594 in 1942 and $83,194 in 1945. The operational metrics are equally staggering, featuring well over 746,000 total combat sorties flown throughout the conflict. During these relentless engagements, the forces sustained 3,499 combat-related aircraft casualties, alongside 1,723 losses from non-hostile incidents, resulting in an exceptionally low attrition rate of 0.7% per mission. Furthermore, these aviators achieved a dominant 4.6-to-1 victory ratio in direct air-to-air engagements against enemy interceptors. The sheer volume of ordnance unleashed by these squadrons highlights their devastating ground attack capabilities, encompassing 132,000 tons of dropped explosives, 135,000 fired rockets, and a mind-boggling 119 million rounds of 50 caliber ammunition. Throughout the European theater, their confirmed tally of destruction included 3,916 hostile aircraft eliminated in dogfights, another 3,022 obliterated on the tarmac, 9,000 locomotives shattered, 86,000 rail cars disabled, 68,000 motorized transports wrecked, 6,000 armored units dismantled, and 60,000 horse-drawn conveyances neutralized. This relentless technological evolution fundamentally shattered pre-existing paradigms regarding how military strategy should be formulated and executed. Before the outbreak of global hostilities, established doctrine strictly segregated the application of aerial assets, assigning heavy bombers exclusively to strategic industrial targets, pursuit craft solely to achieving air superiority, and specialized attack planes to close infantry support. Yet, this formidable machine seamlessly amalgamated all these disparate functions, ultimately securing massive strategic victories through the persistent application of localized tactical strikes. By systematically dismantling the enemy's logistical networks, these fighter bombers managed to accomplish objectives that years of high-altitude strategic bombardment had previously failed to secure. As April of 1945 arrived, you could see that German battalions were completely paralyzed during daylight hours. Their supply pipelines had entirely ceased to operate, and desperate frontline reinforcements remained hopelessly stranded. The sheer accumulated weight of these localized aerial assaults had effectively transformed tactical battlefield interdiction into a crushing strategic triumph. Post-war analytical surveys of the bombing campaigns concluded that these specific fighter-bomber sorties had managed to slash German forward rail circulation by an astonishing 75% by the third month of 1945. This catastrophic paralysis of the transport grid undeniably accelerated the collapse of the opposing forces far more efficiently than the methodical obliteration of manufacturing hubs by heavy bomber formations. Consequently, the overwhelming triumph of these versatile planes compelled the military establishment to drastically rewrite its fundamental combat philosophies.
When the newly independent United States Air Force published its premier instructional manual in 1947, it explicitly declared that the artificial boundary separating pursuit and attack airframes had become entirely obsolete, mandating that all fighters must possess ground strike capabilities and all attack platforms must defend themselves in dogfights. This directive represented a profound repudiation of the 1935 Army Air Corps guidelines, which had stubbornly insisted that a pursuit squadron's solitary purpose was securing the skies, and that any diversion to alternative duties only degraded their primary effectiveness. Ultimately, this rugged aircraft demonstrated beyond any doubt that operational adaptability exponentially magnified a military's overall combat lethality, proving that a plane capable of both dogfighting and bombing was infinitely more valuable than a specialized interceptor. The core philosophy behind this heavily armed juggernaut proved so incredibly visionary that it permanently dictated the trajectory of international aerospace engineering in the decades following the Second World War. By the time hostilities erupted on the Korean Peninsula in 1950, the direct lineage of this machine, specifically the F-84 Thunderjets and F-86 Sabres equipped for ground assault, completely monopolized the skies during tactical engagements. The unified multi-role framework originally pioneered by these World War II aviators had seamlessly transitioned into the undisputed standard for modern aerial combat doctrine. The spectacular evolution of this airframe under the guidance of Republic Aviation stands as the ultimate testament to the absolute pinnacle of American industrial ingenuity. The visionary architect behind the project, Alexander Cardvelli, deliberately engineered the fuselage with staggering structural tolerances that far exceeded the military's initial requests. When the Army Air Forces asked for a chassis capable of withstanding 6 Gs of force, Cardvelli delivered a reinforced monster stressed for 12. When they requested a modest 500-pound payload capacity, he provided load-bearing architecture robust enough to hold 2,500 pounds of explosives. Because of this extraordinary preemptive over-engineering, frontline mechanics were empowered to continuously implement field modifications, dramatically expanding the weapon's versatility at a pace far faster than any official bureaucratic redesign could ever manage. As a result, the models rolling out of the factory doors in 1945 seamlessly integrated hundreds of practical enhancements derived directly from raw combat experience, all while the assembly lines never paused for a single major structural overhaul. The final quantitative metrics perfectly encapsulate this unprecedented industrial miracle. 48 months of non-stop fabrication, yielding 15,683 completed units, spanning 28 distinct configurations. Through the simultaneous operation of dual manufacturing hubs, they achieved daily output peaks of 35 airframes, churning out 430 unique modification kits, and simultaneously driving down overarching expenditures by 27%, despite massively multiplying the aircraft's lethality. The fundamental concept behind the P-47 fighter bomber profoundly shaped the blueprint of every military combat aircraft that followed in its wake. We can trace its direct lineage through machines like the F-84 Thunderjet, which propelled this core philosophy into the jet age, and the A-10 Thunderbolt II, an aircraft that proudly inherited both its name and its dedicated ground attack mission. Furthermore, the F-105 Thunderchief expanded upon this foundational doctrine, taking the strategic fighter-bomber paradigm to entirely new heights. Beyond these direct successes, you can observe the aircraft's conceptual DNA in a wide array of legendary multi-role platforms, starting with the F-4 Phantom II, where versatile control capabilities were woven into the very fabric of its design. This same evolutionary path transformed the nimble F-16 Fighting Falcon into a top-tier strike platform, repurposed the dominant F-15E Strike Eagle for devastating surface attacks, and defined the F/A-18 Hornet as a dual-role fighter from the moment it left the drawing board. Today,
The F-35 Lightning II stands as the ultimate realization of this multi-role vision, effectively replacing heavily specialized airframes. Because the P-47 had already established the ultimate golden rule: engineer a robust, highly adaptable machine and allow the shifting demands of combat to dictate its ongoing evolution. The exhaustive training regimens originally crafted for those flying the Thunderbolt instituted rigorous benchmarks that continue to govern military aviation to this day. When you look at how contemporary aviators are prepared for a diverse spectrum of duties, ranging from aerial dogfights and surface strikes to reconnaissance and electronic warfare, you are witnessing a versatile methodology first championed by these historic squadrons. The mandatory 200 hours of pre-combat flight preparation became the universal gold standard for post-war militaries across the globe, while a strict focus on instrument navigation, tight formation maneuvers, and pinpoint weapon delivery forged the professional criteria defining modern aerial warfare. In the aftermath of the conflict, surviving Luftwaffe veterans repeatedly pointed to this formidable American machine as a primary catalyst for Germany's ultimate downfall. Crucial historical context emerges from the verified accounts of Adolf Galland, who spent considerable time testing captured American airframes following the cessation of hostilities. During a notable 1996 interview, he commended the exceptional comfort, steadfast reliability, and inherent flexibility of the fighter, specifically marveling at a power plant that, in stark contrast to German engineering of the era, remained completely free of oil leaks. Rigorous statistical evaluations thoroughly back up the anecdotal evidence provided by these former adversaries. By the closing stages of the conflict, the German air arm struggled to field a mere 100 functional interceptors on any specific day, a catastrophic decline caused not by a shortage of airframes, but by the systematic obliteration of their fuel reserves, airstrips, and supply chains by relentless Thunderbolt sorties. Ultimately, this tactical platform managed to secure the very objective that massive strategic bombing campaigns had struggled to realize: the absolute and complete paralysis of the enemy's operational capacity. Furthermore, utilizing a fighter-bomber framework yielded a staggering level of economic efficiency when contrasted with the conventional heavy bomber fleets of the era. If you examine the financial burden of delivering a single ton of ordnance, the B-17 Flying Fortress demanded $28,000, and the B-24 Liberator required $24,000. In remarkable contrast, the P-47 Thunderbolt accomplished the exact same destructive task for a vastly reduced expenditure of just $4,200. The human and logistical equations were equally compelling, as delivering 100 tons of explosives cost an average of 8.5 aviators in a B-17 and 7.2 in a B-24, whereas the Thunderbolt suffered merely 0.9 pilot casualties for the same output. Ground support logistics mirrored this disparity. While heavy bombers necessitated 47 maintenance personnel per ton of ordnance, the agile fighter required only 8. The underlying mathematics proved absolutely irrefutable, demonstrating that these versatile planes could unleash devastating firepower at a mere 15% of the financial cost and exactly 10% of the human capital demanded by their massive 4-engine counterparts. Watching a dedicated interceptor mutate into a tactical strike weapon capable of hauling half the payload of a B-17 Flying Fortress represents far more than a simple battlefield adjustment. It perfectly encapsulates the American talent for pragmatic, on-the-fly innovation. The Luftwaffe completely failed to anticipate this metamorphosis because the very concept shattered their rigid philosophies regarding highly specialized combat machinery. While the German military establishment relentlessly pursued flawless performance within strictly segregated categories, seeking the ultimate pure fighter or the absolute best level bomber, the industrially minded American doctrine prioritized rugged versatility and overarching efficiency. Through its remarkable service record, the P-47 emphatically demonstrated that raw flexibility
will always triumph over narrow specialization in the brutal theater of modern combat. When German aviators clashed with these machines over Eindhoven on September 17, 1944, they were confronted by much more than just hostile aircraft. They were staring down a fundamental revolution in martial strategy. The supposedly cumbersome, overweight interceptors that Axis forces had so quickly disregarded back in 1943 had suddenly morphed into the primary engines of their own annihilation. This devastating effectiveness was not achieved by dominating a single, isolated flight metric, but rather through an unprecedented and lethal versatility that caught the enemy entirely off guard. The combat ledger compiled by this formidable platform across the European theater between 1943 and 1945 ranks among the most triumphant chapters in the annals of military aviation. In terms of sheer performance, the D variant could reach a maximum speed of 433 miles per hour, or the M model pushed that boundary to 470 miles per hour, all while maintaining a combat radius of 450 miles with external tanks and a service ceiling of 43,000 feet. This was bolstered by a staggering maximum bomb capacity of 2,500 pounds and unparalleled manufacturing triumphs, which saw 15,683 units completed, including a monthly peak of 150 airframes. Over the course of its manufacturing lifespan, production costs plummeted by 27%, yielding 28 distinct variants and facilitating over 430 recorded field modifications. The metrics detailing its battlefield impact are equally staggering, encompassing 746,000 total sorties flown, with a miraculously low loss rate of just 0.7% per mission. Achieving an aerial kill ratio of 4.6 to 1, these squadrons unleashed 132,000 tons of high explosives and obliterated more than 224,000 confirmed ground targets. The reality that the Luftwaffe could never fathom a single-engine fighter hauling half the ordnance of a heavy bomber shines a bright light on a profound lesson regarding technological innovation. Despite their mastery of specialized engineering, the German High Command completely missed the impending reality that American forces would simply erase the boundary separating fighters from bombers, forging a weapon that dominated through ubiquitous competence rather than isolated perfection. The radical evolution of the Thunderbolt from a high-altitude interceptor into a rugged attack aircraft did far more than catch Axis defenders off guard. It permanently redefined the very nature of aerial combat. You can find the vital lessons extracted from this exact transformation embedded in the structural DNA of every modern warplane taking to the skies today. The hefty fighter, once mocked for its inability to outturn a nimble Messerschmitt, ultimately morphed into the decisive weapon that turned the immense tide of the Second World War. By demonstrating that the 7-ton juggernaut dismissed by enemy tacticians as overly cumbersome was actually their ultimate doom, the platform proved that victory in modern conflicts belongs to those who swiftly adapt to shifting realities, rather than those who obsess over rigid specialization. Because the German hierarchy lacked the imagination to foresee a fighter wielding half the destructive payload of a B-17, they inevitably forfeited their aerial dominance, their tactical mobility, and ultimately the entire war. To this day, this unprecedented metamorphosis stands as the historical benchmark, proving that dynamic tactical adaptation will always spawn strategic revolutions, and that ignoring such paradigm shifts will condemn even the most disciplined armed forces to absolute ruin.